Sorry. All right, so too bad I didn't have that recording. Could have got that on. Okay. Any questions about the pattern? Okay, this is just to explain it. All right. So here's this important thing for today. Michelle was asking about this earlier. Never leave a power with the exponent 0. Instead, write a value of 1. So for example, if we have a, b in brackets to the exponent 0, what does that equal? 1. Because everything in the brackets has a value of 1. So let's try these. Okay. Copy down A. Show your work. Copy down B, C, and D. And one, we're looking at 4 plus 6 because we're multiplying, and then minus 10 because we're subtracting. That gives us 20 exponent 0, and then we have to evaluate that to 1. Okay. B, we already did example right above. The entire base equals 1 because of the exponent on the outside. What does C equal? 1. What does D equal? Well, 1 plus 25, 26. So don't get lulled into 1, 1, 1, 1. Only the base with the exponent has a value of 1. Okay. Any questions? Yeah, Taylor.
For D, since you're adding it, would it be 4 plus 5 and then do that?
Nope. You have to bed mass, right? B, E, D, M, A, S. You got to do your exponents first before you add, okay? So you got to figure out their value first and then add them up. Okay, negatives. So let's just look at this pattern up above here. Each time here, I divided by 10. And I can do that one more time. I can go 1 divided by 10. That equals the exponent, negative 1. Oh. What if I had 10 to the negative 2? What would that equal? 1 divided by 100. Whoa, this is crazy. You've never seen this before. Now, what about 10 to the negative 3? What does that equal? 1 over 1,000. Where we're actually getting this is this equals 1 over 10 to the positive 1. 1 over 10 to the positive 2. 1 over 10 to the positive 3. So what do negative exponents give you? What's the answer in the middle called? It's that F word.
Fraction.
Fraction, you're right. So good of you to guess that. Okay. Okay, so negatives. First of all, then we're going to start with negative bases. Never write answers with brackets. Okay. So if the power is negative and you have an odd exponent, you write it as a positive base. Okay. So for example, right here, this will be negative 1 times 12 exponent 5. So we move our brackets and the negative sign stays. Over here, we would write negative 5. 4 plus 7 is 11. And then we would fix it. Because the exponent is odd, should negative sign stay? Or should this become a positive final answer? Negative sign has to stay. You've already seen this. You know that, right? This is a review of what you've done already. Talking about odd exponents and even exponents. Don't copy it down word for word. Try and put in your own words. Here, we write it as 12 exponent 6 because it's going to be a positive final answer because it's an even exponent. Here, the first step is to give us a -7. Exponent is 4. And so then, because we have an even exponent, it's positive. Okay, so this sums everything up. Odd exponent, you're going to have a negative base. Even exponent, change your base to positive. I guess I should pause that, eh? So never write an answer with a negative exponent. That's a major no-no. And you decimal calculator lovers, never write decimal answers. We don't want you using your calculator. You need to use your brain. Brain smart, calculator dumb. All right? So never write a decimal answer. I will not give you any marks. So we already talked about this example. You don't need to write it down again if you already did. We're talking that each time you divide by 10. And so that's how we get exponent 1. And then 1 divided by 10, 1 divided by 100, 1 divided by 1,000. So what we have to do is change this into 1 over 10 exponent 1. This 1 over 10 exponent 2. And then evaluate this 1 over 10 exponent 3, and then evaluate. Okay? Any questions? Okay. Okay, so instead what you want to do is flip the power over a fraction line to make the exponent positive. So if we have 5 to the -2, we first of all flip it over the fraction line. We write a 1 up top. Okay, 5 squared below. And so then we evaluate 5 squared. 1 over 25. Gesundheit. Good thing you had some Kleenex there. Well, she had to deal with that for the first half of the class. Oy, oh, that's funny. Okay, what are we looking at? Oh yeah, so what if we start with a fraction? What if we start 1 over 6 to the -2? What are we going to have to do there? Well, got to remember the flipping rule. 6 squared, you got to flip it. Okay. You could, now if you really want to, you can write over 1, but it doesn't make a difference. Okay. And so then this equals 36. Any questions? Okay, try some. Okay. Yep. Yeah. So if you had something like this, Meaty, like a negative 4b squared, that's going to be b squared over a positive 4. Sound good? So just drop it down or bring it up. That's all. Yep. You four need to be quiet. Is Sean? You're already in my bad books because Mr. Farley kept going on about the dance where you were where you weren't supposed to be, and he couldn't figure out you weren't supposed to be there. That's right. I think there's a push-up party coming up pretty soon. Plus, yesterday, you're passing the ball when you should be running the ball. That's bugging me even more. Okay, 2,097,000. Let's focus here, kids. Give me 152. Okay. Oh, by the way, Xander, that was a great steal on that rock there. That was good. Hey, let's focus. So, change this to 5 over 4 to the positive 4. So you have to flip both of them. Top and bottom have to flip. So that equals 5 exponent 4. Ah! 5 exponent 4 over 4 exponent 4. Now evaluate the top and the bottom. $625. Hey, happy feet, settle down. Hey, 4 exponent 4. 256. Okay. All right, see how well you know this stuff. Do the next two. Okay. This one here, 2 exponent 1 plus negative 3. Got to add them up because you're multiplying. Now evaluate.
Oh, I get it.
Right? We have to use the exponent rules there.
Whoa.
Interesting shirt. Do you know what the Latin means?
I don't even know what it is. I just picked out because it was colored.
Oh, look cool. Did you really? I would have done the same, don't worry. So 1 over 4, 2 squared.
Here's what it was.
1 over 4.